Hi, I'm Mrs. Kessler from Walsh Jesuit High School, and this section is on the concept of a function. So first, a function is, for every x value, there is one and only one y value. So that would be something like you could have a point here in x, and it would go to a point here in y. Okay? You could also have a point here in x, and you could have a point here. You could have another point in x, and those could both go to that same point in y. Something that is not a function, though, is if you had a point in x that goes to a point in y, but then that same point would also go to another point in y. Because if you look at that definition, for every x value, there is one and only one y value. In this last example, for this x value, there are two y values. Another way to see if something is a function is by using the vertical line test. So if you draw a vertical line in your graph, it should only touch one point. So if we draw a vertical line here, it only touches one point on that line. Same like something here. So let's go ahead and try it on this parabola. If you draw a vertical line anywhere on this graph, it only hits the line once. Now if you have a parabola that's actually turned sideways, if we draw a vertical line, it hits both times here. So that means this is not a function. And then finally, if we use the cubic function, if you draw a vertical line anywhere, it only hits that line once. So that means that this is a function. Now let's go ahead and talk about functions that are represented by f of x. You could have h of x, g of x, it doesn't matter. It's the same thing as using y. It's a different way of writing it. So if f of x is x squared minus x plus 4, if I want to know what f of 3 is, I put 3 in wherever I see x. So that means I'm going to have 3 squared minus 3 plus 4. So in this case, I will have 9 minus 3 plus 4. So 9 minus 3 gives me 6, plus 4 will give me 10. So f of 3 is 10. Now let's try it with negative 4. We have negative 4 squared minus a negative 4 plus 4. Because every time I see x, I put in negative 4. So this becomes plus. Negative 4 squared is going to give me 16. Then plus 4 will give me 24. Now you don't only need to put in numbers, you could also actually put in this binomial here of x plus 1. So if I want to know what f of x plus 1 is, I put x plus 1 in every single time I see x. So that means instead of writing x squared, I'm going to write x plus 1 squared. Then instead of writing minus x, I want to subtract that whole x plus 1. Then I want to add 4. So from there, make sure you actually take this and write it twice in FOIL. So you have x plus 1 times x plus 1. This negative sign gets distributed. So minus x minus 1 plus 4. So here I get x squared plus 1x plus 1x plus 1, then minus x minus 1 plus 4. So when I combine all my like terms, I have just 1x squared. Here I have 2x minus x will just give me plus x. And then I have 1 minus 1 plus 4 will give me plus 4. So this is f of x plus 1 is x squared plus x plus 4. All right, let's go ahead and look at some more properties of functions. Now, you can add two functions together, subtract them, multiply, divide, and then our last one is a composite function. This is f of g of x. Every time you say of, you want to put a parenthesis. So f of g of x, then close your parentheses. And I'll do some examples of that in just a short while. So let's go ahead and look at this. If g of n is 3n minus 2, f of n is 2n plus 1, I want to know what g times f of n is. So that just means you can write this as g of n times f of n. And you simply just take those two functions and multiply them together. So you have 3n minus 2 times 2n plus 1. You want a FOIL, so we have 6n squared plus 3n minus 4n minus 2. Combine your like terms, so you have 6n squared minus n minus 2. So that would be my function of g times f of n. All right, let's try another one. Now, if I have 3f plus 5g of n, so you can write that as 3f of n plus 5g of n. So that means that I want to multiply my f of n times 3. So you have 3, then in parentheses, negative 3n minus 2, then plus, take my g of n and multiply it by 5. So I have 5, and then parentheses, n squared minus 5. So distribute your 3 and your 5 and combine like terms. So I have negative 9n minus 6 plus 5n squared minus 25. When I combine my like terms, I have 5n squared minus 9n. Negative 6 minus 25 is going to give me negative 31. So this is going to be my new function. All right, let's go ahead and look at another one. Now this is that composite function, f of g of x. Okay, so that's what that looks like fog with that open circle. So every time you say of, you want to put a parentheses. So f of g of x, and then close your two parentheses. So I want to take my g of x, which is my x minus 1, and I want to work in my innermost parentheses first. So I'm going to plug x minus 1 in for this g of x. So you want to do f of, now, x minus 1. Now, wherever I see an x up in my f function, which is right here, I want to put x minus 1. So really I do 3 times x, but instead I'm going to do an x minus 1, then minus 5. So I'm just going to take this and just put it right on top of that x right there. So if I distribute my 3, I get 3x minus 3 minus 5, which will give me 3x minus 8. So that would be my composite function. All right, I've just got one more example for you. And now let's say if I did f minus 5g of negative 9. Now I don't have that x anymore, so what I want you to do is f of negative 9, then minus 5g of negative 9. So let's find out what f of negative 9 is. So we're going to plug negative 9 in for a. So we have 3 times negative 9, then minus 5, and I'm going to multiply it with negative 9, plug it in for a. So I have negative of a negative 9 minus 2. So it actually becomes positive. So 3 times negative 9 is a negative 27, then minus 5 times 9 minus 2 is going to give me 7. So then I have negative 27 minus 35. So that right there is going to equal negative 62. So that's going to be my final answer of when I plug in negative 9. Alright, so if you have any questions, make sure you stop in the math office, or you can email me at custerc@walshjesuit.org. I'll see you in class.